All right, so today we have Qian Li and Peter Kraft. They are co-founders of DBOS, which you can find at dbos.dev. So in the website, here's a few taglines. Your compute platform for reliable backends. The easiest way to build cloud-native backends. So I don't know what the official pronunciation is, but based on that description, maybe we can pronounce it as DBOS.
Yep,
Yeah.
that's how we say
It is the boss of all backends. So with that long-winded introduction, welcome to the Data Exchange podcast.
Thank
Thanks,
you.
Ben.
All right, so first off, I guess let's have a description of what problems you are trying to solve. So by problems, I don't mean necessarily academic problems, but concrete problems. Like, are you trying to help people build better stateful applications? So
Yeah, exactly.
are you helping them with the cost of serverless and so on and so forth? So yeah, so let's start with the problems that you are trying to tackle, the concrete problems.
Exactly. And DBOS helps you build highly reliable stateful applications. So we have an open source library that you can add to your program, add some lightweight annotations to your program, and it durably executes your program to make it resilient to almost any kind of failure. And what this means is that under the hood, it stores the execution state of your program in a database so that if your program is crashed or interrupted or restarted, when it restarts, it can look up what it was doing, its past state in the database, to recover from exactly where it left off.
So,
And that makes,
so actually, Peter, let's back up. So let's first focus on the problems you're trying to solve, and we'll go to the solution. So
yeah.
the specific problems that you found are wanting for solutions. So in other words, you before you even built DBOS, what did you observe?
So, as we've been seeing a lot in industry where people write a lot of error handling code and code to, for example, if your server crashes, especially for stateful services, you have when you restart, you can't just restart from beginning. You have to figure out the ongoing tasks in the background, and then you have to resume from where it left off. And also you need to handle tons of failures because like nowadays, stateful applications often rely on third-party tools and or third-party APIs. Those APIs may fail at any time. So you have to do a lot of error handling. So when we talk to people, some of the engineers said like 10% of the code is that the actual like business logic, and 90% of the code is error handling, failure recovery, stuff like that. So we think we see a huge opportunity to help people reduce that burden. Yeah.
So Peter, what can you tell our audience at a high level? So what sorts of applications are we talking about? The concrete applications that encounter this problem.
Great. So actually, this might be a good time for us to go into our demo because that shows a concrete use case.
Okay, so listeners, you might want to switch over to the video version.
Yep.
Refund.
Okay.
So let's say that you're trying to build, so let's say that you're trying to build a refund agent. And this agent, you want it to, it's an AI agent that you want to have it that has a chat interface, and you want it to be able to manage repeat refunding orders. So here's an example of this kind of agent. And what's especially tricky about this kind of agent is that you might sometimes want to escalate certain refunds, such as refunds for particularly expensive items to a human.
So quick question, Qian. So for our listeners, so the question that's typed is, can you help me? provide your order ID, and then the agent is looked up the order ID. So I assume in this case, this agent has access to the right data at the right time. So in other words,
Hear us.
these are scenarios where the agent is hitting real systems. I don't know what they would be, like the order system, Stripe, FedEx, if they want to track where the order is, and so on and so forth. So it's not hitting a data warehouse or something
What do you
like that,
do?
right? So it's actually hitting. So this is an example that I've actually been talking to people about, Peter and Qian, which is basically a lot of people seem to be focused on RAG, which is
Yes.
unstructured text, but reality is agents need access to real-time data
Yeah.
Yeah.
So
in order to be interesting.
yeah. So if you look at this, our agent sent an email to me, and it escalated the refund request to me, and it requires someone to handle it. And then now I say I approve it, and then I would say, what's the status now for order one? Okay.
Yeah. So let's go through what happened here. So we need this agent to interact with the real world. And in this case, we need it to interact with the real world in a stateful and asynchronous way, where I want to escalate to a human and then wait potentially hours or days for the human to respond, and then take actions when the human responds. So I need my agent to do things that are long running and asynchronous. And that's hard. That's not easy to do. Like that's not easy to do. You need code because the callback can take a long time to process. You need code that can remember what was happening, so that if the person takes a day to get back to you and approve your refund, and if your server, if there's some server maintenance, your server's restarted during that day, your code remembers that when the person clicks the link in the email, it's ready to handle that notification, finish processing the refund, and then when somebody asks about the refund, say it's fully refunded.
So does this in this scenario, that you built an agent that already knows the question in advance in the following sense, right? So you ask a question of, hey, what's my order? You happen to have a direct connection to the order database or whatever, right? So it's not a case where here's a question and then I have a model that decides, okay, so based on this question, I should look up the data in this system instead of that system. So there's some kind of routing logic involved, right? So in this case, you already know in advance. So you set up the connection between the agent and the system where the information is, correct?
Yeah. So in this case, the agent, one of the tools the agent has is it can look up any order in the database. So if you ask it about an order and it needs to know more about the order, it'll look up the order in the database using this tool.
Yeah.
So there's no ETL involved, nothing, no pipelines, just basically direct lookup, right?
Yeah. I think, and the part we really want to highlight here isn't so much the lookup, it's the mechanics of doing the refund, where that's a long-running asynchronous process where it has to escalate to a human, wait for the human to get back to it. So you have human in the loop. We escalate to a human, wait for the human to get back to it, and then process the refund if the human approves it. And we think managing that building a tool like that, a tool an agent can use that's long-running and asynchronous, is really hard in most existing agentic systems. But if you add DBOS to them, if you use DBOS to orchestrate your tools, then it becomes much easier. So,
And right now, if someone were to build this today without DBOS, so
Yeah.
I guess what's the state of existing tools?
So if you were to try to build this without DBOS, you'd have to start calling into third-party services. You'd need one way you could do it is you could have the escalation, like you could have the escalation say call in like
You can talk to a task queue, for example, to asynchronously process this.
yeah. For example, you could set up some lambdas. Like one way to do is you might want to you could set up some AWS lambdas that handle approving and rejecting the refund, and then have send an email where the
You mean
links.
when you say setup, it's just running all the time.
So,
One way is to, if you want more dynamic, then like you can ask the agent to trigger a Lambda,
I see.
and then you can ask the AWS Lambda to queue a task into SQS or Kafka. And then when you send the email, after you send the email, you can have another Lambda to receive the email and then dequeue a task from the queue. So you can do this without DBOS, but it may require gluing like 3 or 4 different AWS services to do it.
And obviously the amount of code will explode, right?
Yeah.
And so what happens if I require multiple systems, right? So in this example, you just have a lookup in a database with the orders, right? So what if I need to hit FedEx or Stripe or something like that? What happens then?
Yeah, so depends on the AI framework you use. You can just use DBOS to write additional tools to pass into like to your agent, saying, I have a FedEx lookup tool, I have a CRM lookup tool, I have other like data lake lookup tool. You can just write them in normal functions and pass into your agent for the agent to use.
yeah, I think the key here is that DBOS isn't replacing the framework you're using to write your agent. You can still write your agent in LangGraph or CrewAI or whatever tool you're using. But if you need your agent to do something if you need your agent to access a tool that's asynchronous or that's long running or that executes multiple steps needs to be reliable, then you can use DBOS to write that tool. And that lets you write agents that do things like escalate to a human and wait for the response, schedule tasks to happen in the future. If you want an agent that will send an email not now, but in a week, DBOS lets your agent call a tool that runs asynchronously and sends an email in a week or performs some action a long time from now.
Yep.
Or if your agent needs to execute a bunch of steps and you want to make sure it doesn't get interrupted midway through those steps, then DBOS will make sure that if the agent starts that flow of steps, all of them will always complete.
But so it seems like you still require some sort of access. I think my thesis is a lot of these agents will require access to real-time data at the right time. So, like I keep going back to this example, right? So I need to look things up in FedEx or in Stripe or in Salesforce.
Right.
Otherwise, the agents are trivial, right? So
Right.
they're not that interesting. So would DBOS help me, assuming I have API access to external systems? How does DBOS help me access information from these external systems?
Yeah, so you can absolutely write a tool that will make an API call to another system like Stripe or FedEx or here to Postgres to look up information that can help you build your agent. I wouldn't say it's exclusive to DBOS. You can do the same thing if you built your agent using LangGraph, for example. That's a problem that I think is pretty well studied and pretty solved by people building agents right now. Where DBOS really helps is where the agents have to go beyond looking things up and start taking actions in the real world.
I see.
Oh,
I see.
and just to add another thing is when you talk to FedEx or Stripe, those systems may have glitches, may be temporarily unavailable. So DBOS, especially with the durable execution, we can automatically retry it for you. And also we wrote our own like Stripe subscription system with DBOS. So if Stripe gives you a callback or something, DBOS can correctly process those events. And yeah, that's another kind of cool thing with DBOS, like event processing.
Oh, I
So
see.
when you talk to external systems, if they call back, we can make sure that each event is processed exactly once. Yeah.
Yeah. So I think the problem with these calling external data at the right time, I think people are using function calls and they're kind
Right.
of uh, uh, brittle and hard to maintain.
Yeah,
Right.
exactly.
So I think there are some people working on this kind of real time, right data at the right time, but not enough people are working on it, in my opinion. So anyway, so existing tools, right? So you obviously listeners are familiar with the actual serverless platforms, right? And
Yeah.
you mentioned that, if you try to go down this route, you can do that, but then there's still a lot of scaffolding that you need
Mhm.
to do on your own. So, what about just uh, since is DBOS 100% open source, by the way?
The library, there's an open source component, which is the library that actually makes your applications durable by storing their state in the database.
Yeah.
And then we have a hosting platform that is closed source.
Yeah.
But you can use everything. You can use any application built with DBOS. You can run it anywhere. It doesn't need the hosting platform. The hosting platform is for running it serverlessly at scale.
And so, what is the relation? Is there a relationship between DBOS and Postgres?
We build on top of Postgres. We leverage features of Postgres, and we look forward to contributing back to the Postgres community. But yeah,
So,
and
so
DBOS can support any Postgres compatible databases, not just like, so on the cloud, you can choose to use RDS, or you can also use serverless database Postgres solutions like Neon or Supabase and others. Yeah.
So the natural community where you folks start is the Postgres community, which is huge, right?
Yes. Yeah.
And let's see. So DBOS itself, as I recall, the name is Database Operating System, right? So isn't this kind of, as I remember, so this has been a few years ago, but so I remember the vision is modern operating systems act like databases in some ways. So why not just build an operating system on top of a database? Am I wrong in my kind of genealogy in terms of origin story?
Yeah, so that was the DBOS research project, which we worked on as grad students alongside, my advisor Matei Zaharia, alongside Mike Stonebreaker at MIT, and we worked on that academically, and we chose to commercialize it. The particular problem that we focused on commercially is this is an insight that came out of our research is what happens if you store the execution, maybe not the entire state of the operating system, but the execution state of your program in the database. Like that was the idea that we took from the research project and decided to commercialize. Because we realized if you build, a library that stores the execution state of your program in the database, then that can make it much easier to do the things we've been talking about, to build highly reliable, stateful programs.
So what are some of the early, I guess I'm not familiar with how old the company is, but what are some of the early kind of users outside of the company? What have they been building and what kind of use cases?
Yeah.
Great. So as the company goes, we started about a year ago, and then we've been launched for about 6 months. Let's see, a couple of, so
Yeah, so I mean, I can talk about like our early adopters. So one of our early customers, actually, they really love us. They wrote a blog post about us. We can share the link later. Their use case is to integrate Shopify, and so they receive updates events from Shopify through Kafka, and then they use DBOS to reliably store the customer information to like your CRM, your database, and many other external systems.
And
So
what were they doing before?
they actually this is their new feature. TMG is our one of our early adopters. So they were prototyping with this project with AWS Lambda and step functions and Event Bridge and many other AWS tools, but they found it super hard to glue things together. And then they spent 2 months on AWS, but wasn't very successful. And they found DBOS and built everything in 2 days.
The key is that what they're trying to do is they're trying to reliably read data from Shopify through Kafka and write it to several systems on their backend. And this sort of gluing together of many different services is really common type of application. But building it, especially if you want to build it reliably so that you actually ingest every piece of data and you actually write it to every single backend system, is really hard. And they ended up with a labyrinth. When they tried to build it, with following best practices in AWS, they ended up with a labyrinth in architecture where they needed, like Qian said, 5 or 6 services, step functions, Lambda, Event Bridge, API gateway, just to get data from one place to another. And they needed those services because they needed reliability, because they needed to make sure that they were reading each event from Kafka exactly once, making sure that each event actually gets into each of their backend systems. And they needed all these different services to orchestrate this data movement. And DBOS, they're able to write it as just one TypeScript application that they serverlessly hosted in our hosting platform. So it, like Qian said, massively simplified the development process.
It sounds too good to be true, but I trust that it works. But let's see. So that in that particular example, it's more of a kind of, I guess, data ops, data engineering, data infrastructure. So is that kind of right now, 6 months into the company, is that kind of the sweet spot? That's the community that's resonating with DBOS?
So we see broadly 2 trends right now. One is more for data engineering, that was the first example. We also have people building data pipelines with DBOS to ingest documents, for example, to your RAG or to your machine learning models. And then the second branch is actually what we demonstrated, the agentic workflows. Like when people are trying to build those very dynamic AI tools, they're using DBOS to make sure that things are reliable and things are recoverable. If something goes wrong, they can resume from where it left off.
Can you elaborate on the RAG example?
Yeah. So let's say you're trying to, specifically it's the data pipelines you need for RAG. Let's say you're trying to ingest 10,000 documents, and that ingestion might take several hours, and you want to make sure that every one of the 10,000 documents actually gets ingested. So that's tough, because let's say that over the course of those 8 hours, something breaks. Your server's restarted, your pipeline's interrupted, and you've only ingested 4,000 documents. And now you have to figure out, if that happens, you have to figure out which documents were ingested, which weren't, and I have to go back and ingest the other 6,000 documents. And what DBOS does, it lets you write a pipeline that, once that is durable. So if you tell it to ingest 10,000 documents and it crashes halfway through, it knows which ones are ingested, it knows which ones aren't, and it'll automatically resume and ingest all the others.
So it takes care of a lot of things that normally you would have to hand code yourself.
Yeah.
Yeah.
I see. So same thing, I imagine, Peter, same thing. If once you ingest the documents, can DBOS help me kind of make sure that I'm embedding every chunk into a vector database, that kind of part of the pipeline?
Right.
Yeah, so it orchestrates the entire ingestion pipeline so that you know that every single step actually happens, no matter how long it takes, no matter how long running your pipeline is, no matter what goes wrong in between when you start and when every one of your documents is fully ingested.
Yeah.
Yeah, I guess I never really kind of thought about what people were doing. I just assumed that, it's a data pipeline. People are doing it. But then obviously, as you point out, as the scale goes up, most likely things will go wrong.
Yeah.
And you will have to take care of all of that error handling yourself right now, right?
Yeah,
Yeah.
and which is what people are doing.
And
Yeah,
so then with DBOS, it's based on the code you showed, probably the reduction in code is probably like 50, 100x, I would imagine, right?
that's what we hope. Yeah, so when we talk to people, it's kind of it's a tricky problem to solve. Some people are just like restarting entire pipeline every time, so which is not efficient at scale. And yeah, that's one problem DBOS can help to solve.
So you're 6 months in, and this might be an unreasonable question, right? So,
Mhm.
but are there are there users who've come to you and say, "Hey, because of DBOS, we've saved 50x on our cloud computing costs," or some kind of savings? Do you have some kind of savings anecdote at this point?
Yeah, so like the customer we talked about earlier, the ones doing the integration, they actually did a webcast with us that we can send you a link to in a blog post where they said that this project had been taking months before they discovered DBoS, just a prototype, and DBoS they had a prototype done in a couple of days and got into production in a couple of weeks. So that is almost a 10x improvement in development and developer velocity, where something that wasn't working started working because they started building it with DBoS.
So again, so same thing, same example, but same type of question, but I'm sure you have an answer for this as well, right? Let's take that RAG pipeline where you do the ingestion, embedding, and so on and so forth, right? So obviously DBoS simplifies error handling, but does it increase uh, latency and time, the overall compute time, or so what is the relationship between DBoS and speed, for example?
Yeah. So DBoS is doing one database write per step in your pipeline. And a database write is taking on the order of a millisecond, and the steps in your pipeline are taking on the order probably of like minutes. So the overall addition of latency is likely negligible for the types of tasks that we're seeing people use it for.
Okay. And so then at this point, what are some of the features that you guys would want are working on for the next, let's say, 6 to 12 months?
We're further improving the developer experience for our platform, for our library, and for our cloud platform. So yeah, I think what we are trying to do now is to recruit more users and collect feedback from them.
And
Yes.
right now, it seems like the languages that you target are Python and TypeScript.
Yeah,
So that's one thing we're working on, adding more.
yeah, we're adding more
Yeah, it
languages.
seems like I don't know if this is the case, but I mean, I think Java is still a big thing in enterprise, right?
Yeah,
Yeah.
Java, Go, like we really we'd really love to have a compiled language on our list. So we're hoping to add one. We're working on adding one in the.
And so what about if someone approaches you and say, "Hey, I love this, but we're not Postgres or something else. We're using a different database," right? So,
Mhm.
So yeah, the one nice thing about the way DBoS is architected is that it uses Postgres almost entirely as a black box, or you can treat it as a black box. So DBoS does need Postgres to store all of its data, but you can store your own data somewhere else. So even if you are like the first customer I talked about, their data is in Salesforce and SAP. But that's fine because they can allocate a small Postgres database, or we can host one for them for their DBoS data, and they treat that database as a black box that DBoS uses internally, and then their actual data is stored somewhere else, and that's completely fine. DBoS orchestrates their program, and they don't need to worry about Postgres at all.
so
Right.
black box, Peter, brings up the possibility of making it harder to debug
Oh, it
and
so
analyze. Yeah.
if you so the database is just a normal Postgres box. You don't have to worry about it because we provide interface to query to get the status, but you can also directly connect to it and use SQL to analyze what's going on, to analyze your execution state.
Yeah, I should have said you can treat it as a black box. It's all there, and you can do anything you want to it. And it actually can really enhance the observability of your program if you want to dig into it. But you can also not worry about it, and DBOS will handle the orchestration for you.
Yeah.
So you guys are former academics, so surely you must have benchmarks
Yeah.
to kind of validate the kind of the readiness of the technology, right?
Mhm.
So feel free
Yeah.
to tell our listeners any benchmarks that you have.
So, two relevant performance benchmarks we did, both against AWS systems. So, one is against AWS Lambda and step functions. So that's AWS's serverless technology and their orchestration technology for serverless functions. And we compared the performance of a database workload, of a multi-step database workload in DBOS and in step functions, and found that DBOS was like almost 25 times faster. And that's because in DBOS, every transition between steps is just a database write. Whereas in step functions, to transition between steps, that you complete a Lambda, you then wait for the step functions orchestrator, which is remote, to asynchronously dispatch another Lambda to do the next step. So it's a millisecond per step transition versus hundreds of milliseconds or seconds per step transition. So compared to other technologies for building reliable programs, because DBOS just needs one database update per step transition, it's orders of magnitude faster.
By the way, I'm looking at the site here. You have a feature that I think is kind of cool, which is you allow developers to replay and inspect past executions, right? So kind of a time travel
Yeah, exactly.
feature. So I don't know if that's actually something that you might be able to hand code and build all of this error handling, but I guess you can do this too, but it's great that this comes for free almost, right?
Yeah.
Yeah, because your state's stored in the database, we
You
can
can
remember
replay,
what your
yeah.
program used to be doing, and we can replay it.
And
And we're in a world where we know something will go wrong at some point, and usually the things that go wrong involve a pipeline, right? So
Yeah.
it does really make it important that you can really debug and inspect and really understand pipelines, right?
Yeah. And also, we integrate with open telemetry traces. So you'll be able to see what's going on and integrate with your other systems or services that are using open telemetry.
Let's drill down a little bit on the AI world, which you mentioned two things, RAG and agents, right?
Yeah.
So in on the RAG front, are people aware of you at this point? I mean, it seems like more people should be using you. Do you have relationships, for example, with the vector database or vector search providers and so on and so forth? So what's the level of awareness among RAG builders about DBOS?
Yeah, so this is a space we actually entered very recently. So we launched DBOS, and most of this work is done in Python. We launched DBOS Python less than 2 months ago.
Yeah.
So we're new to this space, and we're working on building relationships, particularly with the AI frameworks like Llama Index and LangChain. We actually did a cooperative blog post with Llama Index about serverlessly hosting AI applications just a little while ago.
And you're neutral when it comes to where these embeddings land, right? So you can play nice with all of the vector database providers, right?
Yeah, exactly.
And then on the agent front, how would you describe yourself to someone building agents? Like what part of the I guess this is the problem with agents, right? So we don't have there's no consensus what's the right stack for agents, right? So but in the absence of that, so how would you describe yourself to a developer who's building agents?
Yeah, so I would say you can use DBOS in two ways. One, if you have already picked like LangGraph or Llama Index or Cruella or any like AI framework, you can use DBOS to build tools for your agents. So like you can build authentication tool, you can build an email sender or email verification tool for your agent.
And the
Or
key here is that DBoS helps you build asynchronous, reliable, long-running tools that you can't build with LangGraph by itself, but you can build with LangGraph plus DBoS.
yeah, and then the second thing is if you just get started, if you want a more like lightweight agent framework or agent workflow framework, you can use DBoS together with other tools to build the AI workflows from scratch as well.
So I have to admit I haven't tried DBoS yet. And this might be an unfair question because you folks are representing DBoS, but what's the state of the documentation for someone who were to go to the docs after listening to this podcast, interested in trying it out, not necessarily the cloud service, but the open source project. So
Yeah.
how would you self-grade yourself as far as the documentation?
I think we're
Yeah.
pretty happy with the state of it. One thing we actually recently launched. This is from the cloud. This is using the cloud service to help make it easier to try out the open source. Is a GitHub integration where you can launch your first application entirely on the browser. It creates a GitHub repository for your application with a template already installed. It launches your application in DBoS Cloud. And it also sets up a Postgres database for you hosted in DBoS Cloud. So then you can start developing locally with the open source framework from that GitHub repository and using the cloud-hosted Postgres database.
And this is free, you're saying?
Yeah,
It's free.
yeah.
And regarding the docs, we are pretty proud of our docs. We think it's clear. Also,
But I guess specifically in the docs, these two things that people are super interested in right now, RAG and agents.
Yeah.
There are a lot of
we
documentation.
have examples for that.
Okay.
We have plenty of examples for both use cases.
Yeah, one thing we're proud of is our examples page, which has, I think, 10 or so different real applications built with DBoS with fully annotated code. And with all open source, with fully annotated code on the docs page and full explainers of how that code works. So that includes.
Yeah. Here is our docs. You see it?
Yep. Nice. Yeah.
So you can see a lot of examples like how to get started with OpenAI and Llama Index. And we build a LM-powered chatbot with LangChain.
Yeah, here's the right example right here.
You can use DBoS. This tells you how to ingest your data into RAG.
Nice.
And how we built a AI-powered Slack bot. So if you're interested in integrating with Slack, DBoS can make it super easy for you. And if you want to do some cron jobs to ingest your data or scrape your data, DBoS can also help it. So yeah, so we're pretty happy with the featured examples page. Yeah.
So are there specific verticals where you think that this will really resonate? So for example, I'm thinking maybe finance, e-commerce, or manufacturing, IoT. I'm not sure exactly how much outreach you folks have done to these specific verticals. So it might be worth it, for example, for you guys to develop content that targets them, for example.
Yeah, I think the verticals that are most interesting, not necessarily sectors, but particular problems such as data integration, such as data pipelines they cut across verticals, but there's usually a specific team in any given company that's building them and that we are trying to build content that appeals to those specific teams.
By the way, one thing that I'm actually in the process of writing about is this notion that in this generative AI world, especially as things increasingly become multimodal, we'll need better data processing and data prep tools. For example, with video, for example, right? So maybe some of the steps in the data processing is CPU bound, others are GPU, right?
Yeah.
So, I mean, a lot of the tools we built in the past were focused on structured data. It seems like you folks don't really care from that perspective, you're still going to be useful, kind of whatever data processing tool I use moving forward, you might still be a useful tool. Is that correct?
Yeah, I think we provide is really lightweight orchestration, and that if you run a long-running pipeline, a pipeline with many steps, a pipeline at scale, we make sure that pipeline actually does all the steps.
Yeah, actually, now the pipelines, the data pipelines require AI.
Yeah.
Because, for example, right, so take a bunch of documents.
Mhm.
Step one in the pipeline, I remove all personal identifying information,
Mhm.
or I translate all the terms into English, right? So that
Yeah,
might be using some kind of LLM, and then you go chunk and then embed, right? So
exactly. Yeah.
yeah. So the data processing tools themselves will change, I think, moving forward.
Mhm.
But uh, it doesn't impact, as Peter was saying, you folks can still provide kind of that orchestration layer,
Exactly.
whatever tool I'm using.
Yeah. Yeah, exactly.
Interesting. So, any last words to our audience if they wanna try out or get involved with DBOS? Are there meetups? Are there webinars? Or is there a YouTube channel? Anything that you wanna talk about?
Yeah, so if you want to get started, definitely, I think, like we mentioned earlier, I think our quick start makes it really easy to get an app off the ground, deployed in the cloud, and then working locally on your computer in a couple minutes. And if it takes you more than 10 minutes to do this, let us know so we can fix it.
Yeah.
Our community is most active on Discord, so definitely check us out there. Links on our website at dboss.dev. And we also regularly post updates on our development process, what we're building, and technically what we think the most interesting parts of DBOS are. Both of us post those on Twitter regularly and on
And
LinkedIn.
LinkedIn and Blue Sky these days.
So
Yeah.
follow us on those platforms.
I would suggest actually you folks start developing video content, short
Mhm.
YouTube videos, or even, believe it or not, live coding on Twitch or some streaming
Yeah.
platform. Because then what you do is, here's in this session we're gonna do this with DBoss, and then you're doing it, and then you can post a video after,
Mhm.
right?
That's
So
a good point. So actually, it's on our agenda. So one of
because a lot of people now are learning through video for some reason. Yeah.
yeah,
Yeah.
we can, yeah, that's a good idea. We can show that.
We are becoming old school in that we're learning through docs, right? So yeah.
Yeah.
And with that, thank you.
Thanks, Ben.